I am Monish Mani P of URK25CS1080. This is my COA Practicum 1. Develop solutions that perform arithmetic operations based on the input size and complexity analysis. So, this is the practicum in which we perform operations like addition and subtraction for the 8-bit unsigned 8-bit integers, 8-bit addition. So first we are getting the input of integer a, b, and then the choice of 8 or 16. If the choice is equal to 8, a value is equal to unsigned integer of 8 bit, it is converted, and then b value is converted into unsigned integer of 8 bit. 8-bit integer, then the sum value, that is a variable created so that a variable and b value is added, and then the sum is printed. If the sum is greater than 255, it will display overflow is occurred in the 8-bit arithmetic operation, and then the increase in data width to 16-bit to avoid the overflow. This will be printed, and then here is the next one. If the value is less than 255, the value will be displayed as no overflow is occurred in 8-bit arithmetic info. It will store the value of a, b, and some value as an array in the format of array, and all will be added, and it will be given as the total bytes. So the total memory used will be given, and the memory per value is 1 byte, and the data type used is 8-bit. So if the choice is 16, a variable is converted into unsigned integer of 16a, and b variable is converted into unsigned integer 16. Then the value of a and b is added. Then the 16-bit result is of the both added values are printed, and no overflow in 16-bit arithmetic is also given. Then the value of a, b, and the sum variable is stored as an array which is equal to the info variable. Then the total bytes is calculated. Then the data type used and the memory per value is 2, and the total memory used is also printed. So this is the 8-bit addition. Here is the 16-bit addition. 16-bit addition the same. U int of a is converted into 16-bit, and then b value is equal to u int of 16b is converted, and then the same is added. If both is added and the value is greater than 65535, then overflow is occurred in 6-bit arithmetic, and then the increased data with 32-bit to avoid overflow is given, and then no overflow is occurred if the value is less than 65535. Memory usage information is given. Data type used is 16-bit, and memory per value is 2 bytes, and total memory used is the total bytes that we have given. So 8-bit subtraction, now we are going to see. Enter the first value, second value, converting into unsigned integer, 8-bit of a and b, and then subtraction of a and b is happening. Both is subtracted so that the value is not, if the value is always less than 0 and not more than 0. If so, the value is that, then the underflow is occurred. If not, no underflow in 8-bit arithmetic subtraction is happened, then the data type used, memory type used, total memory used is given. 8-bit subtraction, a input and b input is got, and unsigned integer of 16-bit a and unsigned integer of 16-bit b, it is converted, and then a variable and b variable is subtracted. If the value is less than 0, underflow occurred in 16-bit arithmetic is given, and then use unsigned into 16 or increased data with is also displayed. If so not, the condition of no underflow in 16-bit arithmetic subtraction has happened is given. Then the data type used, memory per value is given, and the total memory used is also given here. 8-bit multiplication. Input of a b is got, and u int 8 conversion of no, integer into an unsigned integer of 8-bit is done like the same of b, and then both the variables are multiplied, and that happens a check if double a and double b is greater than 255, overflow is occurred, else no overflow. Then value of a, b, and multiple variable is told as an array, and then data type used memory per value, and the total memory used is also given. 16-bit multiplication. Yeah, value a and b are got. Then conversion of integer into unsigned 16-digit integer. Unsigned integer of 16-digit integer of b is also got. Then multiple variable a is equal to variable a and variable b are multiplied, and then the overflow is checked if the value is more than 655 35, and the overflow is occurred in 16-bit arithmetic multiplication. If not, no overflow is occurred. Then the data type used memory per value, and the total memory used is also given. 8-bit division. Enter first integer value, second integer value, conversion into 8-bit unsigned integer is done. Then the performing of 8-bit division is happening here, and the division result is printed if the value is if the value is if the value is less than greater than 255, overflow is occurred in 8-bit arithmetic, and using of u int 16 or higher data width is also happening, else no overflow in 8-bit arithmetic division. Data type used is 8-bit, and then memory per value is 1 byte, and the total memory used is the total bits that is calculated. 16-bit division. CLC clear. Then input of value a and value b is got, and the unsigned it is converted into a 16-bit unsigned integers. Then the 16-bit multiplication will happen. Then the check for overflow is happening here. So the memory usage information is got by converting a value, b value, and multiple value into an array, and then sum of that. Then the data type used is 16-bit, and the memory per value is 2 bytes, and the total bits used is given is also given. These are the steps performed, and here is the conclusion. Thank you. Here is the output results. Thank you.